All right, ladies and gentlemen, let's take a look here at number 41. Okay, so number 41 is a factored quadratic equation.
You have to identify A, B, and C.
In a standard form quadratic equation, you would have to identify A, B, and C. Very good.
Is it a quadratic, and then you have to find what um
You're on the right track. You're doing good. You're remembering and recalling a lot of good information
have to
about
find out what it
quadratics.
multiplies to and what it adds up to be.
Yes. Now you see everything you're saying. Hold on to those things until we get to question 43, and that will all become super relevant. And might even have you repeat some of that. But in this case, they've done that work that Becca was referring to. They've already done it for us. They've given us the factored form of the equation. This is the thing that Becca was just describing, that process. They've already got this process done for us. So all we have to do, these are called binomials. Okay, so when you hear me say binomial, I'm referring to something like this with two terms separated by a plus or minus sign. So we set each binomial equal to 0. Okay, so these are called factors. This particular brand of binomial is called a factor. And so you solve each factor for the variable.
So you do the additive inverse.
Exactly. Do the additive inverse. And so in this case, P equals -5 and P equals -2. So there's actually two answers. Normally when you do a math problem, there's one answer, but P actually equals both of these things, because in a quadratic equation, like this one, a graph of the equation would show that let's see, they both cross at negatives. The graph would look something like this, where this point right here is -2, and this point right here is -5. So these are called the zeros, or the solutions, or the roots, or the answers, right? You know, this is what they are. These are also the x-intercepts of the graph. So that's what you're finding when you're solving. You're finding the x-intercept. That's question 41. Question 42 is the same exact type of question. So let's write that down. Remember, for full credit, or let me rephrase that, for any credit, we're going to need you to go ahead and write everything I'm writing. The theory being, if I'm doing the work, then the least you can do is do the work. I won't ask you to do any more work than I do, but no less either. Seems fair. Equal work, yeah. All right, so let's set each factor equal to 0. So here, b minus 6 equals 0, and 7b plus 1 equals 0. So here we're going to do the additive inverse, plus 6 plus 6, b equals 6. And here we're going to do the additive inverse, but we'll still have 7b on the left equal to -1. And the final step will be to divide both sides by 7. Cancel, cancel. B equals -1/7. So this graph, were we to draw it, will cross the y-axis at -6, and it will cross the x-axis at 6 and -1/7. So something like that. Okay, so where this is 6 and this is -1/7. See that? That's how it would look if graphed. But you're really only caring about the 6 and the -1/7 there. Moving right along, ladies and gentlemen, moving right along to number 43. and now we'll see what Becca was reminding us about. This is a standard form quadratic equation.
You have
So
to identify A, B, and C. Then you have to find what multiplies to 0.
you're real close. And the amazing thing is we only talked about this a little bit and you're remembering a lot of it. So yeah, first let's identify A, B, and C. Remember, the standard form of a quadratic is ax squared plus bx plus c equals 0, where we refer to a and b as coefficients of these two variables here, and then c is called the constant. So a in this problem is 1, b is positive 8, and c is positive 12. Okay? So step 1, you need to determine what the master product is. This isn't really relevant for these simple quadratics, but it's good practice. The master product is A times C, which is equal to 1 times 12, which is just 12 in this case. Okay. And what you need to do is have two numbers whose sum is B. So I need two numbers whose sum is B, and B is 8. And whose product is the master product, which is 12. So think of two numbers that when you add them up, they're 8, and when you multiply them, they're 12. 4 and 3. So 4 plus 3 is 7. But 4 times 3 is 12. So that meets one of the conditions, but not both of them. Try again.
6 and 2.
Very good. 6 and 2. So we have 6 and 2 and 6 and 2. 6 plus 2 is 8. 6 times 2 is 12. Now the next step is crucial. We're going to rewrite this standard form quadratic in factored form. So we do an open parentheses, and then we write v plus 6, close the parentheses, open up a new parentheses, and then we put v plus 2, okay, equals 0. So just, I want to say this, this top equation here equals this equation right here. Okay, they're equal to one another. They're just different forms of the same equation. Now, set each binomial factor equal to 0 and solve for v twice.
So that means you do additive first. Then
V
you have to
plus-
divide by the coefficient of the variable.
Yes, but in this case, the coefficient of the variable is 1, so we don't have to
B.
divide. Okay? But it's good to know that kind of academic language, right? She's using the good academic language. Yep, always a good job. So v equals -6, and then subtracting 2 here, v equals -2. Okay, so there's your answers. That means this graph, if this curve were plotted, it would cross the x-axis at -6 and -2. Okay. Okay, let's take a look at number 44. Number 44, x squared plus 10x plus
So it's just
24.
like 43, which is, it's a quadratic.
Mhm.
So you have to identify A, B, and C.
Yes, let's identify A, B, and C. A is 1, B equals 10, and C equals 24. Now, tell me two numbers that add to be 10 and multiply to be 24. Two numbers that add to be 10, 6 and 4. 6 plus 4 is 10, 6 times 4 is 24. Okay, so we can just jump, we can just jump ahead here and write the factored form. x plus 6 times x plus 4 equals 0. X plus 6 equals 0. X plus 4 equals 0. And then we do the additive inverse. Minus 6 minus 6, x equals negative 6. Minus 4, x equals negative 4. And those are your answers.
This is not hard.
No, no, it isn't. And just like that, we're on number 45. X squared minus 40 equals negative 4. X squared minus 40 equals negative 4. X squared minus 40 equals negative 4. Okay, now let me do all the talking for this problem because we haven't encountered a problem like this before. You notice it looks different than the previous two problems. It's not a standard form quadratic. So the first thing we got to do is make sure the right side is 0. Okay. So we're going to add 4 to both sides. And then I'll have x squared minus 36 equals 0. Okay. So negative 40 plus 4 gives me negative 36. Now here it's important to notice something. I am missing that middle part. Okay, so if Becca told us identify A, B, and C, we have A is 1, and we have C is negative 36, but what's B?
That'd be 1.
It's missing.
Yeah,
Okay, so in reality, I'm going to come back to this. It's got a special name, but in reality, this equation is x squared plus 0x, so please write this down, minus 36 equals 0. Okay, now try in your mind to think of two numbers that add to be 0 and multiply to be negative 36.
36. 1 6 times 2.
What?
36 no, because that would be 0.
You need the numbers to add to be 0 and multiply to be negative 36.
0. 36. Negative 36.
But if you multiply 36 times 36, it'd be a heck of a lot bigger than negative 36.
I don't know.
How about 6 and negative 6? So they add together, they annihilate one another. They're 0. The sum is 0. The product is negative 36, right? So it's x plus 6 and x minus 6 equals 0. Okay?
Then you set both of them to 0.
Set both of them equal to 0.
And then you solve for x. You do the additive inverse.
Very good.
Mm-hmm.
Very good.
Oh.
So x equals negative 6 and x equals 6. When you see an equation like this, okay, this means that this equation is centered on the y-axis, okay? There's that missing middle term means that it's centered on the y-axis. The y-intercept is negative 36. So way down here at negative 36. And then it comes up like this. And it crosses the x-axis at negative 6 and positive 6. Okay. I'm just showing it to you. So
Wait,
you
no, I had a
just so you see it. All right. Can I go? All right. Next up is number 46. n squared minus n minus 33 equals negative 3. Number 46, n squared minus n minus 33 equals negative 3. Okay, remember the right side must be 0. So what must be my first step?
Set them to equal to 0.
Somebody was saying it. Thank you, Brendan. Plus 3 on both sides. So I'll have n squared minus n. Negative 33 plus 3 is negative 30 equals 0. Okay, now I need two. So Becca would tell us identify A, B, and C. A equals 1, B equals negative 1, C equals negative 30. Okay, so I need two numbers that add to be B, negative 1, and they have to multiply to be negative 30. It's a brain game.
What is it? Say it again.
Just tell me two numbers that multiply to be 30.
30?
3 and 10, but you can't. Negative 6 and positive 5. All right. So if I have negative 6 plus 5, that equals negative 1, which is B. And negative 6 times 5 equals negative 30. So those are my two conditions. So it's negative 6 and 5. So those are my factors. So I'm going to write n minus 6 times n plus 5 equals 0. Now set each factor equal to 0 and solve for n twice.
To be the additive inverse.
Okay, there it is. 6 and negative 5.
Wait, is it 6 or negative 5?
Yeah, positive 6 and negative 5. That's number 46. And now we're going to move on to a fun new type of equation. I love these. We shouldn't be allowed to have so much fun in algebra. Why do they let us have this kind of fun?
To make up like for all the work you have to do. I think that's why.
All right. So I have the square root of x plus 10. And that's equal to 5. You know how Becca's always saying do the additive inverse? What do you think the square root inverse is?
It'll be 10.
No. You're on the right track though about multiplying, but it's think about what the inverse operation of square rooting something would be.
Divide.
So you know when Becca's always saying additive inverse, if it's positive 5, the additive inverse would be subtract 5 to undo the plus 5. So I need to somehow do something to make this square root go away. What do you think I should do?
You divide by both sides by 1.
Lots of good ideas. Here's the answer. To unsquare root something, you square it. So place the whole thing in parentheses and put a squared symbol. And remember what we do to the left, we must do to the right. So square 5 as well. So on the left side, you just have x plus 10 now because you squared the square root. And that equals 5 squared. What's 5 times 5?
10 and 25.
25. And now you just solve this for x. Subtract 10 from both sides. X equals 15. You thought it was gonna be a lot harder than that, I guess, huh? Yeah,
That's when you divide it
I
by
knew it, I said it
one.
was 15.
we're done.
Oh,
X equals 15.
15.
Let's do number 48. Okay, same idea on number 48.
B is 15.
you square it.
Right, so let's take a look at number 48. We have the square root of x minus 2. That equals 9.
Then you add 2 on both sides.
So what do I do? Look up here, please. I'm hearing conversation. What should I do here? Square it. So put parentheses around this and square it. And then you have to do the same thing here. Put parentheses around this, square it. On the left side, you have x minus 2. Yeah, what's that? 81. Thank you. Okay. Now we add 2 to both sides. X equals 83. Okay.
This is 83. I just saw that. Huh?
Okay, I heard somebody say, what time is it? And that's my signal that we've probably reached the limit of our attention, which is good. That's good.
No, we got one more.
Okay.
Good morning, happy.
We got one more.
Yeah, well, but they become more complicated, so I'm going to stop there. Good job today.